Hello, welcome to CAD in BIM, where we train civil and structural engineers. My name is Lucas Chacha and I'm going to be your instructor. In this tutorial, we are going to learn on how to insert columns and do paneling and prepare our model, save our model at TXF file ready for importing to protastructure like this one here. So we like to convert or to prepare our model from where we left the other time, where we had put our grids. You can see these were the grid that we ended here. So this we are going to pick it from. So the next thing immediately, once you put your grid at the center of the walls, remember we are considering walls but not the existing columns. So you have to clean up our model. You have to clean up these walls, clean up everything, you clean up here so that you avoid errors when you are importing into protostructure for analysis. If you doesn't clean it up properly, it will give you some errors and your model will not work perfectly. So having said that, let's get started. This one was our model, so you can pick it from here. So we do the cleanup. So doing the cleanup of this, I can just copy this model, right click. You can copy to another, because I have already done a model that I don't want to interfere with. So I'll just copy this file to somewhere else, to another folder, just see what I'm doing, so that also when you're doing that, you will not have issues. So just come here, say copy, and then come to draw. The model is here. Actually, you can just right click, then come there, then just say paste. Just come and paste it there. So you do your cleanup here. So once you do your cleanup meaning that you will be selecting like our one line here, then right click, say select everything, and then right click, say erase. Come here. You are only supposed to be left with the grids only. So everything else that is not grid should be deleted, including the dimensions. So like dimension, just come here, select everything, and then right click, erase. Anything that is not grid should be eliminated, including these columns here, because now as a structural engineer you will be using the knowledge you have in deciding. So I can just assure you this is not very difficult to do. So select erase. So my model is becoming cleaner and cleaner. Select again. So go on doing that everything until you erase. So once you do your cleanup, I think your model will not be having these columns here. You can also do the cleanup here. So to make this video short, so ensure that you have cleaned up everything. Select and then just erase. Yeah, so you just make sure that your model is very clean. So you just have this line here, select. That one is selecting the whole. So let us just assume that you have cleaned your model. So you'll have something like this one at the end of the day. Let me copy this model. Come to clipboard, copy. So let me just paste it here. So once you do your cleanup, let me just leave that wordings there. So once you do your proper cleanup, you will have something like, Okay, technically, let me just also do this so that you see. You select. I'm just trying to make it to make my video as short as possible. So you'll have your model, just grids only. Select, yes, select here, and then delete. So this is how you'll have your model looking like. This is the only way you'll have your model. So from here you start putting your columns, and putting your column. Now you'll have to come and change your layer property. You choose the column, because at the time you are drawing this grid, you are using the grid columns here. As you can see, if you just click here, let's say maybe you want layer, then you just come and click here, it will turn to grid because all these one are drawn in grid. So you now come, take column, change it to column. Then now, with the knowledge you already have, you review your architectural template. Let me just review it and see. You realize that here we don't have columns here, so we'll be having a very long beams. And based on the knowledge that we learned the other time, on how to orient our columns, actually on how to orient our columns, then you realize that the shorter side of the column should always be perpendicular, or the width of the column should always be perpendicular to the longer side of the beam. So, and because these will be needing larger beams because of a longer span, maybe longer than the wall, which is 225. 225 is the wall width, so we'll be needing at times beams that are longer than that. So meaning that we can have beams that are not square. So we'll be having to maintain the wall. I don't know if you are getting what I'm saying. This is what I'm referring to. Let me come back to my AutoCAD here and come here. You can see the width. This beam here, I think we just did a wrong dimensioning. Let me redo it. Well, just erase this and erase this. Come to dimension it here and here, and then so that's 225. Then start it from here. So this is what the architect gave us, a column of 225. 225 is technically the width of this wall. If you take maybe your measurement and measure from here, that's not even to here, that's 225. So when you are doing your wall, you want them to flush with the wall. So that's the idea. Generally, we don't want to interfere with that. So meaning that we'll be maintaining our width and increasing the depth of our column. I had discussed this in our previous video. I'll do also a recap immediately after this video. So how are we going now to decide the dimension of our columns? Because now I want to place our column in this clean grid. I think this was the drawing here. No, this was the drawing here in this grid here. So this is what we'll do. We'll come. Remember also we have columns that are edge columns that do not carry a lot of weight, and those could be maybe a column of 225 by 225 will just be enough, and the column, but however the center column 225 looks smaller. So we'll try to have two type of column, which is 225 by 225 and 225 by 350. So to draw that, ensure that your property layer is in the column. So this is what you do. You just come now, click on polygon, just ensure that you are at the orthogonal. So go do 225, enter, then do 225, enter, 225, enter, and then 225, enter. simply have it there. And then come pick, you can only use polyline or rectangle, don't use just this line because you want to have something that is enclosed. So click here, now do to 225, 225, enter, and then do 350, enter, go up to 25, enter, then just come and close this. This one you can maybe copy and rotate depending on, this is a copy, rotate, sorry, just first select the element, then just say rotate right 90 degrees, enter, pick here, sorry, come to rotate, choose your center of rotation, this one, 90 degrees. Yes, oh, I ought to have copied it first, so just do a copy. Sometimes AutoCAD is, so this to give us variety of orientation, because you can either orient them vertically or horizontally depending on the bending moment, major line of major bending moment. So this one should now be rotated so that my, actually you can write 90, just click that to ensure that it's orthogonal. So these are our columns. So like the edge columns can just be okay by us taking this one here. So we will use the edge column for, this was my arrangement or my idea of orienting this column. So this is like the edge column here. I can just put the 250, the square columns, and then I can do it all along. So you can see I did all this because I don't want to waste or to make this video as short as possible. So that's how I placed all these columns here all along. So if you look at my plan here, that's why I wanted us to maintain it so that it doesn't interfere. Yes, so you can see this is these columns here are square columns of 250 by 225 by 225 all along the edge of the columns or places that they have shorter spans. So I can see even I had just forgot placing some columns here, or even here we had a beam here, so they are supposed to have some columns there. So this is how we did them. So when we come now to our second beam, which is here, we realize that we'll be having very long beams here. So you can see, let me open the architectural template. You just have to understand that. So these are long beams because this is a laboratory, this is like a hall, to ensure that there is visibility or usability of this. So that's why the architect didn't put some column, because they cause some interference. So once you are doing, you'll do a lot of consideration here. You'll maybe use very depth of the beams will be too much, will be bigger. So we just want to maintain this, assume that this is correct, do the analysis. In case of failure, then we'll come and see the mitigations that we'll be working on. So once you have a beam like this, remember this is 450. Let me zoom here a bit. So based on column orientation now, knowledge that I did previously. So this 450, this 450. So this column and this moment here, they will cancel. So we'll be having a moment here of this column here, which is about 8 meters, but however, consider the half of it, that's about 4. So the column orientation should be in such a way that the shorter span of the column is perpendicular to the longer side of this column here. So we'll be orienting our columns in this manner. Let me now go and orient my column properly so that we are together. So come, leave that one alone. I'm just coming here. Now I'll use this column here. Right click, copy, copy the selected, pick the midpoint there, snap at the midpoint, then carry it to here, because this and this will cancel, and then we have a very long beam here. So we just have to orient them like this. You can see the shorter side of the columns perpendicular to the longer side, because these moments will cancel out. So this is how we place our beams all around. So you can place them also here that way. So I didn't even use columns of the same size. I want just to assume this is the best sizing members, and then once I design and then they fail, I can come see the mitigations that I'll do. And also remember this is just a one-story building. It doesn't carry a lot of weight, but we'll have a lot of issue on the slab because of the span. They are past the recommended size. So however, we can try and see what we can do. So this is how you do it. However, for this one, you'll use the square columns as I've done. So this is how you place now your column. So once you place your column, it's now time to indicate where your beams will run, or something called paneling. So you now come, you change your layer from columns to, not from here, you just change it from here, from column to just, you can use even that one. Just say okay. No, don't want to, just come here, click on that. Now pick your beam, pick your line there, come and click on the orthogonal, and then now come click on this and try to locate your next beam. Your next beam here, you can just come and click it there. So you want to create your beams, and then what you do, you just take this one, offset it with the width of the wall, which is 225. Say enter, just offset it there. We have it. Now again, you can now copy this beam here. I'm just showing you what I did to arrive at, and then just select that, also select this one, then right click, copy selected, come and take then the midpoint here, and then now you can be transferring them here like that. You can come again here, you will get maybe another beam, you do it like that. So that's how I did this one. And then maybe you want to do the vertical lines, you can come pick here. I'm just doing this so that to save time. I don't make, but I want you to understand the idea of placing this column. So you just take like a simple line here, pick it there. So these I'm just doing the beams, or what we refer to as paneling. And I want just to show you the idea, because this you can easily do if you are fluent in AutoCAD. And my focus is design, not learning how to model in AutoCAD. So you just say copy the selected, come pick it here, come, yes, you can just come to the right angle, you can just simply do that. Yeah, you just come there. You can see I'm just doing my I'm just doing, just put them at the right angles. Yes, and remember you can always trim where maybe they have overlapped, maybe sometime. In case of overlapping, like here now you want to clean up your model, remember to use the trim and extend. You can just come and trim here, do that. So that's cleaning up our model. You can see, so this is what you do, all this. So once you do like that, then you will have successfully prepared your model. So at the end of the day, you should have something like this one. So as I was working there, I realized that I had omitted placing one of my columns. So click here, copy. So we ought to have a column there. We also ought to have another column here. We also ought to have another column there. Yes. Is it really there? It should be here. See, also our column here cannot hang, so we'll just have to introduce a beam. These are office, and maybe there will be staircase here. So let me also do this one so that you can see. So if I'm here, I can copy this. I can just hold click that, click this, click this. If maybe I want to copy. If you are fluent in AutoCAD, this is not very difficult to do. So you can just come there, just come and place it here. And we have it there. So you also pick, so this is my model that I had prepared, but so you just do the cleanup like this. So at the end of the day, you should be having a very clean model like this one here. As you can see, you can have a very clean model like this one. So you can see the span here. I'm not sure, I think we'll introduce some secondary beams when you are drawing here. But for the columns, they are not there, but you can try and see. I think we need some secondary beam, but we cannot have again beams. So this is our model. This is a cantilever. Remember, I didn't place any beam here. You can see how clean it is. So this is a cantilever all along here. You can see I've really prepared it. It looks nice up to this part here. So this is remember there was a construction joint here. So this is our another one wing. This one will be another wing. So let me open and show you the architectural view of that. Sorry, let me reduce this a bit so you can see we have a construction line here. So you have two wings, this side and the other side. So I think now we are okay. And now what you can do, maybe you can just rename this is the lab. This is also a lab. This is staircase, but for a staircase we just indicate a void. So this lab A, lab B, this side will be for the toilets, this one will be for the ramp. So you can simply come here in a structural plan. So once you have prepared your model, I think I've shown you how all this is done. In case you have any question, please feel free to ask. So you can simply come. So I don't need these ones. You can agree with me now. At this moment, I don't need this one. So I simply erase everything. I'm interested in this model. So maybe you can just copy this, right click, copy selected, and then you can maybe edit it. So that's our ramp. This is the lab okay, can simply rename this one. And also you can simply come here. So that's lab. So then add some. So our model is ready for importing. So this is the staircase, this is the toilets. Yes. So I think we are done now with our model. What you do now, you save it as a DXF file. So if you want to save it, so this is where our lesson is ending by saving our model. Our subsequent lesson will now be on how to import this model to protostructure. So I can just do this highlight and then highlight everything on the model now that you have prepared your structural model. You can see what structural engineer do is very different from what the architects did. Those maybe who are asking what's the difference between architect, even when I was starting, I didn't get the real clear difference between an architect and a structural engineer. You can see what the architect has done, and you as a civil or a structural engineer, what you ought to prepare out of that model that the architect has done. So that's where the difference comes in terms of what we do as our modeling, or the difference between architectural and a structural model. So this is just a simple. By doing this, it will also help you when you're doing detailing. So just by it will help you by dealing. So I was just showing you on how you can save this. So to save this, you just highlight everything, double click, not double click, but type W on your screen, then press enter. Come, select the part that you want to save your model. Here it is the path. So I want just to save as lab structural. It's now plan. I've done it plan 2. But now let me just say it. Maybe plan 4, plan 2, plan 3. And then ensure that now it's not in any other format but DXF file. And I'm using 2018 version, so I'll click it there. So you can now say save. Remember also to check on units. We are using millimeters, so put in millimeters, and then now click here save. Yes, and also before you save it in DWF file, make sure that you have saved your file. So you have to come to home to effect the changes, come to CAD here, and then just click save. Yes, so once you save your model, that's where now you import. Remember to do that, because if it doesn't do that, it will take the initial one that you did before saving. So you have to save your model first, and then just to repeat, you type on Windows W, press enter. So you check here units in there into millimeters, and then you can come also here, check, select the path location. Location is here in this plan 3, so let's just do this plan 4, because there are changes that I did for column. There are 2 columns that I added. So click OK, but ensure that the file type is the DXF. I'm repeating again. Then click OK. Now you can click save. Everything is right. Leave everything the way it is. Then just click save. Yes. So our lesson is ending here. So our next will be on how to import it into protastructure, and then we'll start doing our analysis. Thank you for listening. Let's meet again. Remember to subscribe and comment and like, and I'll, as a way to keep me growing in this platform. Thank you so much.